here we go. We've been talking about what? Solubility. Tom, can you say solubility? Very good. What does solubility mean, Emma Pearl?
We mean if it can be dissolved in water.
That's right. If it can dissolve in water, it's soluble in water. Now, again, we've talked about solubility in other things. Like solubility in oil, maybe. I mean, we've just mentioned it briefly. If you want to use the term or the little AQ, that just means soluble in water. So I'm going to give you a few things, and you tell me whether or not they're soluble. Okay, here's one. B3N2. What do you think? Is this one soluble or insoluble?
Insoluble. Soluble. Insoluble.
Why do you guys think it's insoluble or soluble? What do you guys think?
What?
What are your reasonings?
Well,
Chemistry time.
wait, it doesn't have any group. Where? It doesn't have group 1A.
Doesn't have group 1A.
Well, is there 7?
Doesn't have
There's
group
just 7.
Group 7 is the fluorine, chlorine, bromine, iodine. The halogens.
The one right, the yellow color right next to the last one. Oh, and it doesn't have.
No, here. Let me show you how to count the groups when I talk about the groups. It's like this. Okay, everybody look. I don't want to have to do this over and over. So look. 1, group 1, group 2. Okay? And you skip over to this big box. Group 3, 4, 5, 6, 7, and 8. Okay? So you skip this whole blue transition metal block.
That's what I did.
Okay? That's how it works. So, group 7. Group 7. So what do you think? Anything from group 1A?
No.
Anything from group 7?
No.
No. And even if there was, it has
Okay, that's true. So, soluble or insoluble? Insoluble? Okay, you're correct. Insoluble. Where's my eraser? Okay. Next. Here we go. Ready?
Well, that's soluble.
How do you know?
Because it has nitrate.
All right. It has nitrate. So it's soluble, right? Anything that has nitrate is always soluble. Very good.
Why is it that now it's soluble?
Well, let me tell you the story behind solubility for these compounds. Now, I want you to recognize that I'm going to draw these compounds that I've drawn so far. Oh, well, how many have I drawn? What was the first one we did? Lead. Let's see.
Lead? Don't touch me.
Whoops.
I'm not doing it.
This is called lead, not nitrate, but nitride. Lead nitride. Here's another one that we worked with yesterday. Right? Here's another one that we've seen before. Right? Okay. Here is, oh, we had this one too. When did I have this one just now? Well, here's one.
What are these examples of?
These are examples of different compounds. I'm going to put a box around the different compounds, okay? So you can see them well. I want you to see a pattern in these compounds. There's a pattern.
They all, most of them have C.
Oh, see, that's just by chance, I think. Here, let me draw another one.
They all have numbers.
Wait, what's the rule about? They all have letters? What's the rule about?
Sulfates are generally soluble. Almost always soluble. Sulfates are almost always soluble.
They all have numbers.
They all have numbers, okay. What about,
It looks like all of them
What about metals? Do they all have metals?
Yeah. We don't have a metal and a gas?
Do they all have non-metals?
Yes.
Not metals and the gas, but those are non-metals, right? That's right. These compounds, the ones that we were talking about in terms of solubility in water. Tom, you need to let him pay attention. You can't be bothering him right now. I know you're not bothering him, but you have to talk about that afterwards. These compounds all have a metal and a non-metal. Metals and a non-metal.
So if it's metal or non-metal, tell me metal is normally not soluble. It's normally soluble.
We don't know whether it's normally anything or the other. We have to use the rule. But the point is, these compounds contain metals and non-metals. So if you take something from the metal side, somebody give me a metal from the metal side.
Iodine. No. Gold. Zinc.
Gold. Gold is the first metal I heard. So, somebody else give me something from the non-metal side.
Mercury.
What's that? Mercury is a metal.
Carbon.
Carbon. Carbon. So, AU4C3. And this is called gold carbide. Alright? So we have a compound that has metal and a non-metal. Let's do it again. Another metal.
Titanium.
Titanium. Ti. Iron's
Fluoride.
good for next one. Iron.
Fluoride.
And now we need a non-metal. Fluoride. Titanium. Fluoride.
Neon. Fluoride.
Fluoride. Titanium fluoride. Iron. What's iron going to be with?
Neon. Neon.
All right. Now, the noble gases, they don't like to form compounds, right? So we're really kind of limited in the number of non-metals that we can choose from. Phosphorus, iron,
Helium.
phosphide,
Lithium.
iron phosphide.
Hydrogen.
Another metal is lithium or platinum, I hear.
Hydrogen.
Lithium hydride,
Silver.
that's a non-metal.
Silver is a metal.
And platinum, what should we put with platinum?
Kryptonite.
Has to be a non-metal. Sulfur,
Nitrogen.
platinum sulfide. Okay? Or we could do
Phosphorus.
phosphorus, platinum phosphide. Okay? So, these kinds of compounds that I'm introducing to you all have metals and non-metals. Alright? Metals and non-metals. Alright. Here's what happens when a compound that has a metal and a non-metal is soluble. Let's use an example of this one. Sodium chloride. Does that contain a metal and a non-metal?
Yes.
It does. Is sodium chloride soluble in water?
Yes.
How do we know?
Because it has sodium.
Group 1A and group 7. That's right. Alright, so it's soluble in water. Now here's what happens when a compound that contains a metal and a non-metal is soluble in water.
Is that why salt's so good at dissolving? Because it has two things that dissolve very well.
So it dissolves
No one gave it to me.
and sodium
Carbonate.
separates from chlorine and gets surrounded by the water molecules. So all the oxygens on the water molecules surround the sodium. Like that. See that? Over here, all the hydrogen ends of the water molecule surround the chlorine. Does that make sense? So they're separated from each other. Now, sodium and chlorine came together for a reason. They liked how they felt together. They were sticky. But when water came around, it could convince them to separate from each other. Okay?
Because they had stuff that they liked better.
Because oxygen could supply what sodium needed more than the chloride could. and the hydrogen is supplied with the
Well, that's
chloride.
hydrogen around that one.
This one?
No, that.
This one.
They both have hydrogen around.
Well, they both have the hydrogens and the oxygens, but this side the oxygens are in the middle, are surrounding it, and this side the hydrogens are surrounding it. See that? I'm trying to draw it like that. Now then, hold on just a second. Here's a compound, iron, Fe. N, iron. Anybody want to guess what this one's called?
Nitrate.
Not nitrate. Nitrate was the NO3. Nitride. Nitride. Here's iron nitride. Is iron nitride soluble?
No.
How do we know it's not soluble?
Because it's part.
Doesn't have group 1A. Doesn't have group 7. Doesn't have anything else that's soluble. Right? So it's not soluble. So that means when the water molecules come to try to pull it apart, it what? It can't be pulled apart because it prefers to be its neighbor. Do you have something to say?
Yeah. So does tap water not work as well
As what?
in solids as in just plain water?
Tap water already has some sodium chlorine in it, right? Some sodium chlorine in it. So it's a little less effective at dissolving some things, but not terribly. And some things it can help a little bit with the sodium chlorine have.
Is it better for sodium chloride to dissolve in tap water because
Is it bad?
No, better.
Better? No. If there's, yeah. Sodium chloride has a very high solubility, means that a lot of it can dissolve. Because did you know you can keep adding sodium chloride to water, and there will come a point that what? It won't dissolve, right? Have you noticed that? If you just keep adding more and more and more, at some point it will stop dissolving, and it will make a pile of it.
Because all water molecules are already.
All right, that's right. There's limits to how soluble things are in solution. So, do you know what solubility means?
No, it's the
That's exactly right. Very good. And when something dissolves in water, it separates like this, with the water molecules' help. So if something's not soluble in water, it means it won't what?
It won't dissolve.
Won't dissolve. And essentially what's going on is the water molecules can't convince these two atoms to separate from each other. Does that make sense? Okay? Now, last year, or 2 years ago, when we talked about metals and non-metals coming together to form compounds, you need a periodic table? This gentleman needs a periodic table. That's him. Tom. There we go. When we talked about metals and non-metals coming together, does anybody remember why they like to come together?
Because they like to have this, like, say about a special amount of electrons.
That's right. Sodium and chlorine come together because they help each other, right? Do you guys know how many electrons sodium has by itself? Sodium atom?
Sodium has 11.
11?
No, that's protons.
But that's also the number of electrons.
Oh, yeah.
That's right. It's also the number of electrons. How about chlorine? How many electrons does it have? 17.
Blueberry cheese.
Look on the periodic table, it's the number. Sodium is number 11. And so that's how many electrons it has.
Really?
No, isotopes don't differ in the number of electrons or protons.
Oh, I know why, Dad.
Or neutrons. Yeah?
Sodium wants to lose one, and chlorine wants to gain one.
Yes. Remember how we talked before, how, and I'll tell you this story next time, that sodium and chlorine feel depressed in their lives. You guys know that?
Yeah. What?
They're so sad.
Where is chlorine?
Chlorine is number 17. They're so sad because they're not like the noble gases. Okay? Here's sodium. He's a very handsome metal. And here's chlorine. She's very beautiful. Right?
So if you add them
But
together,
nobody gives them any respect. Right? Now I'll tell you the story. What? Oh, she's has one right by the side right there. She's very shy. So I will tell you the story next class of how sodium and chlorine and why.
You make it.
Okay?
Let's see
We'll
the
see you next
smoochies
time, which is Monday. Is today Thursday?
Monday.
Today's Friday.
Today's Friday.
Everybody pile your periodic tables in one pile right here.
Because my birthday's on Monday. I remember that